First, we'll go to Google and then we'll download Oracle Java from the first site that appears. Then we'll download this version for Windows. Side to side, we can also download JFlap. We have to download this version. Now, after the download is finished, it will ask us for the permissions. Now, to give the next command, then next. Now, it is copying new files. Then we have to give close. Now, we'll go to the JFlap. Now, it is installed. So, the question is obtain DFA to accept strings of zeros and ones not containing 110. We will need four states Q0, Q1, Q2, Q3. We'll make Q0 the initial state. In our given question, Q0, Q1, Q2 is also the final state. According to the question, we'll have the minimum string 110. And then we'll give self transition of 0 on Q0. Then on Q, we'll give back transition from Q0 to Q1 on 0. Then we'll give self transition of 1 on Q0, Q2, and then we'll give self transition of 0 and 1 on Q3. Here our machine is ready. Now we'll check for the tracing. First we'll trace the string 0 0 0 1 0 1. Now we'll go by step. So the first one is 0, it will accept it. Then another it will go to Q1 because we gave the input 1. Then it will go again to Q0 because we are given 0. And then the last one is on Q1 and it is a final state, so my string will be accepted. Now I'll trace for another string. The string is 1 1 1 0. My initial state is Q0, then it will go to Q1 because on the input 1, then it will go to Q2 because we have given the input 1, then it will go to Q3. My string will not be accepted because Q3 is not a final state. Now my next question is pushed on automata. Question is obtain a PDA to accept language A raised to power n, B raised to power 2n, where n is greater than or equal to 1. Now here I'll need three states Q0, Q1, Q2. I'll make Q0 as my initial state and Q2 as my final state. Here I'll give self transition of Q0 on Q0 by giving the input A, and if my top of the stack is Z, then it will give two A's and Z. My next transition will be also be on Q0. On Q0, if my input is A and top of the stack is A, then the stack will contain triple A's. My next in transition would be B. On the top of the stack A, then my stack will eliminate the A. My another transition will be on q1 on q1 on the input b, and if my top of the stack is a, then it will again eliminate it. My last transition will be by epsilon. Also my top of the stack is z, then my stack will contain z. Now my PDA is ready. Now we'll trace it. Now I'll trace for the input double A and 4 B's. As we can see, this should be accepted by the final state because the number of A is 2 and the number of B is 4. Now my first step will be A, so it will contain double A and Z on the stack. My again, if I do step, then it will contain 4 A's and Z. Now in the next step I have to eliminate the A, so it will eliminate the A from the stack. It will contain triple A Z. Another B, so it will contain double A Z. Then I have again another B, then it will contain one A and Z. Then another B, then it will contain only Z. Now my final transition, it will take an epsilon on the top of the stack Z, so it will be accepted. Now we'll trace for another string, that is double A double B. As we can see, it should not be accepted by the PDA. Now when it is A, so it will contain in the stack double A Z. I have another A, so it will contain 4 A's and a Z. B, it will eliminate only one A, so 3 A and a Z will be left. Then another B, so double A and Z. Now there is no transition for double A and Z, so the string will not be accepted. Now my next problem is on Turing machine. My question is, develop a Turing machine to accept string ending with B. Here we'll need three states, Q0, Q1 and Q2. I'll make Q0 as the initial state and Q2 as the final state. Now I'll give two self transition of Q0 on Q0 on the input A, and if my stacks contain A, then it will move to the right side. My another transition would be B, and if the stack is B, then it will also move to the right side. Now I'll give the transition of Q0 to Q1 on blank blank to the left side. I'll give the last and final transition of Q1 to Q0 on B B to the right side. Now this is my Turing machine which will accept the string ending with B. If I am getting A's and B's in my string, it will always move to the right side. If I get a blank symbol, then it will move to the left side. After getting a final B, because it will be the end of the string, then it will move to the right side and it will be accepted by my machine. Now we'll test it for the question triple A and B. My input would be triple A B. As I am containing the first A, so it should move to the right side. It has moved to the right side. Again, another A. It will remain in the same state. Another A. Then I have a B. Then it will move to the right side. Now I have a blank symbol, so it will move to the left side and it will contain to the last. It will go to the last element of my string. So it is a B. So it will be accepted by my machine. Now the string has been accepted by my machine. Now we'll test for another question. B A B A. As we can see, this string should not be accepted by my machine as it doesn't end with the A. Now the first input is B, so it will be in the same state and move to the right side. A, same state to the right side. B, same state to the right side. A, same state to the right side. Now I got a blank, so it will move to the left side. When it moved to the left side, it has occurred A. There is no transition on A, so the string will not be accepted. Now my next question is parse tree with derivations. Now obtain derivation for string triple five using parse tree is given the production. My context free grammar is S will give A, S will also give double A. Now S will give triple A and a S, because this should not give the multiples of A. Now we'll give test, so it will test for the grammar type if it is a context free grammar or not. Yes, it is a right linear grammar, that is regular grammar and context free grammar. Now we'll make the parse tree. My input is 5 times A. So my first node is A. It will then start. Now it has choose the third derivation, that is triple A and S. Now my last S can be expanded as double A. Now the input that I have given 5 times A are the leaf nodes of the parse tree. So my parse tree is correct. My another context free grammar is S will give double A, S will give A and B, capital A and B. S will also give small double A and B, capital B. Now my capital A will give small a. It will again give a capital A and an A. Now B will give a small b. Now I'll test if it is a context free grammar or not. This is a context free grammar. Now I'll test for the string triple A and B. Triple A and B. Now it will start with an S node. Now my S has chosen the first derivation, that is capital A and B. In another step, my A can give a capital A and A, so it has chosen that. My A's leaf node has came. Now my capital A has again been derived to a capital A and a small a. Next, my capital A will be changed A as per the third derivation. Then my B can be turned as B. Now the leaf node is showing triple A and B. So my parse tree has been made for the string triple A and B. Thank you.